So in this recording, we're going to go through the median and the mean. So this is as part of our work on investigating and comparing data distributions. So the learning intention here, and this is obviously over a number of lessons, will be ultimately to be able to identify measures of center and spread and their use in summarizing numerical data distributions, including the use of and calculation of the sample summary statistics, median, mean, range, interquartile range, and the standard deviation, and then choosing between the measures of center and spread. The success criteria will be, and this is hopefully after the recording and then the worksheets, you'll be able to calculate the mean and the median. You can calculate the mean and the median from tables and charts, and you can identify the most appropriate measures of center. So that is based on whether the mean is more appropriate or the median. And we'll go through how to determine when the median is more appropriate than the mean and vice versa. So let's start by looking at finding the mean. So the mean is one way to measure the center of a data set. The numbers in a data set are also known as elements, and the mean is calculated using the following formula. Now, the mean is calculated by adding up all the elements in a data set, or the sum of all the elements in a data set, and then dividing that by the total number of elements in the data set. So we'll go through a worked example to see the mean equation in action. But first I want to go through some of the key symbols that you will be seeing throughout this unit, just so that when you see it, you know exactly what we're looking for or what we're trying to ask you to find. So the first symbol is this X with the line on top, and basically that represents the mean of the data set. So if we come back to this equation up here, the mean is represented by that X with the bar on top. Then we have X, which represents each element in the data set. So that's important. It represents each element. Then we have sigma, which is the Greek letter, and that represents the sum of. Now I do really want to apologize here because I'm not very good at drawing this at all. And then we have the number of elements in the data set, and that is represented by n. All right, so let's actually do a worked example where we need to find the mean of the data set. So what I would do here is obviously go in and add all of these numbers up. Highly recommend that you just use the CAS calculator, but in setting it up, we do 43, and that will give me an answer of approximately, and I say approximately because I do have to round this answer, of 40.73. Now that we know what the symbol is for the mean, I would say actually go in and write the mean is equal to 40.73. Again, if the question hasn't specified, I would just round my answer to the nearest 2 decimal places. Okay, so now we're moving into calculating the median. Now the median does require a little bit more work depending on the number of elements that we have in a data set. So we have a situation where we could have an odd number of elements. So that could be we have 11 data points, or we have 33 data points. And then we have a situation where n could be even. So we could have 16 data points, we could have 100 data points. Based on that alone, we have different routes that we have to take in order to calculate the median. But before we jump into that, the median is the middle value of a data set. To find the median, we need to first rearrange the data in ascending order from smallest to largest. Now this I cannot emphasize enough. It is so important to make sure that your data values are going from smallest to largest, otherwise it will completely throw off what your median actually is. Now I mentioned earlier that we have two different pathways we have to take depending on whether we have an odd number of elements or an even number of elements. So if n is odd, that's the easiest one. The median is located at the n plus 1 divided by 2 position. So all you have to do is find out how many data points you have, add 1, divide that number by 2, and that will give you a particular value. So let's say it equals 11. That means that your median is the 11th value in your data set. Then we have a situation where n could be even, and this is the one where you will have to do a little bit more work, and you do need to be very cautious and take your time in doing it. So when n is even, the median is actually the average of two values on either side of the n plus 1 divided by 2 position. So I've put here an example that goes through, I guess, that definition in words. So let's assume that a data set has 20 elements. So in this example, n is equal to 20. Then the median is going to be found by first doing the n plus 1 divided by 2, so we end up with 10.5 on either side of 10.5, which actually means that we're going to be looking for the median between the 10th value and the 11th value. The median is then actually the average of the 10th and 11th value. So you'll take those two values together, divide that by 2, and that will be your median. Now, the next example actually is a situation where we have an even number of elements, so we'll put that into practice. So the worked example here gives us a data set of a series of numbers, and it says to calculate the mean and the median. Now the mean is going to be easy because we don't need to rearrange any of our values, and just looking at the data set we can see that the numbers are in no particular order. So to find the mean, all we're going to do is add the elements together. So just using a calculator here, we end up with 3,100, and then we have how many data points? We have 10 data points. So in this case, n is equal to 10. So our mean is going to be 3,100 divided by 10, which means our mean is 310. So that was nice and easy. The one that requires a little bit more work is the median. So I'll just do the median in a different color just to differentiate the answers. So then we have the median. So first and foremost, we need to reorder the numbers. Alright, so now we can see that I've reordered my numbers. So the next thing I need to do is actually work out whereabouts I'm looking for my median. So like we calculated earlier, we know that there are 10 elements. So I'm going to do the n plus 1 divided by 2 equation in order to find out where I'm sort of looking. So 10 plus 1, divide that by 2, I get 5.5. Which means that the values that we're looking for are the 5th and 6th value. So I'll just write that down. So I've written here that the values we are going to use to find our average are the 5th and 6th value of our data set. So now that we've got our data set in increasing order, it makes it so much easier. So counting in my 5th and 6th value, so 1, 2, 3, 4, 5. So this is my 5th value at 245, which means my 6th value is 252. So that means that our median is actually going to lie in between that. So to find our median, we're going to do 245 plus 252 and then divide that by 2. And that will give us an answer of 248.5. So there are some limitations or scenarios where the mean is more appropriate to use than the median and vice versa. So I think it's important we go through it so that you know when it's more appropriate to use the median, for example, to find the middle value versus the mean, and obviously the other way around. So I've got here the limitations of the mean as a measure of center. So the mean is affected by an extreme value in our data set. So we know now that an extreme value is usually what we call an outlier. And this is very evident in the following two data sets, right? So we have the first one here and we have the second one. We can see that the median will be the fourth number in both data sets. So remember, with the median, we just do n plus 1. So n in this example is 7. And then 7 plus 1 divided by 2, that will tell us that our median is in the fourth position for both data sets, right? Because we have 7 data values for both. Now, if we were to use the mean, however, so for number 1, if we were to calculate the mean, then we would find that our mean is 6. Perfectly fine. That's what we can see with our median as well. However, in scenario 2, we can see here that we actually have an outlier at 90. So let's calculate the mean for the second data set, and what we should find here is that our mean is no longer going to be 6, and the 90 will actually change the value of our mean. So again, we would just add all our data points together, and our mean now becomes 17.57. So we can see with this particular example here, the mean was not an appropriate method to calculate our average value, purely because it was affected by an outlier. So in this case, the median is much more appropriate, especially when the data is skewed or contains extreme values. So I'm just going to highlight that. Now, when it comes to choosing between measures of centre and spread, so this is like the mean versus median debate, it's always important to consider both the median and the mean to determine which represents a more accurate picture of the data. Take into account any outliers. If there are outliers, then the median is a more appropriate measure of centre, and the median is also suitable when there is skewed data. So I've got a worked example here, which is just of a histogram, and it represents the IQ test results for a group of people. The question asks us to determine which measure of centre is best to represent the data set. So with this data set, the first thing I notice here is that it's approximately symmetrical, and that there are no visible outliers. So due to the lack of outliers and the fact that it's symmetrical, to me, the best measure of spread would actually be the mean. So basically, if the data was skewed and we had an outlier, or it was just skewed or we had an outlier, then this is when the median would be a much more appropriate method. And this would be enough for a justification when you're asked to kind of justify why you think one would be a more appropriate measure of centre over the other.